All right. So knowing who was going before me, I decided to take a little bit of a different approach to this presentation, especially knowing that all of you now know about static analysis and what it is and what the benefits are and all of that kind of stuff. A little bit. So I'm going to talk to you today a bit about the evolution of static analysis and what some of the modern products can do for you. So we're going to kind of go over a little bit of the history. I'll do a quick demonstration of what we are able to accomplish at the desktop for developers. And also we're going to take a look at doing some prevention and detection of defects right at the desktop for developers. So the goal is to make sure that you can cover the things that you need to cover for your preventative measures and detect them as early as possible, as well as making sure that you can ensure the success of the static analysis tools that you are using. So let's kind of jump into the presentation here a bit. So I'm going to kind of split this up a little bit into first, second, and third generation static analysis tools. So in the beginning, there were products like Lint and things like that. And basically, they were just desktop only, looking at the very specific context of the code that you were analyzing, right? So it knew, it was kind of grabbing the low-hanging fruit. It knew, what some of the basic problems were within the context of the files that you were editing at that time. But it didn't really know anything about the rest of your code base or what was going on in the rest of the world. And it wasn't really able to take those things into consideration. So then when you move on to things like your second generation, that's when you introduce your whole program interprocedural analysis, right? So then you're getting even more information, which is all great. But then you kind of lost the ability to have it as a developer tool. It was sort of, at that point taken away, and now it's a little bit less effective because you have to go, wait till later on. But now we have tools today that are basically partial, it's incremental and whole program analysis. It's on the fly. It's right where, right as you're actually coding. Just like a spell checker, you're able to leverage an entire system-side analysis and get the benefits of having that analysis right there at the desktop for you. So I'm going to go over a couple slides with that and give you a little bit of a look at some of the things that we're doing today. And you saw this a little bit of this chart in the previous presentation, basically saying the further you go down in this development life cycle, the more it's going to cost you to fix those defects, right? The good thing is that when you get it at the system build time, you're getting all the information. So you have full ability to know everything about your code base, right? But then it's costing you more, and you're going to have to wait longer. And so a lot of studies have been done about when defects are actually introduced and all of those types of things that are happening, right? So it's always happening right when the developer is writing the code at implementation and build time. So if that's where they're being introduced, that's going to be your lowest cost point when you're looking at when should we be addressing them. And so that's why companies like Clockwork have developed desktop tools, and one of the main products that, one of the main features that we happen to have is called on-the-fly analysis. And that's what I'll show you real quick here. So one thing to keep in mind, one of the reasons that we do something like this is when you're thinking about source code analysis, the thing not to do is write a book, 1,500 pages long, or write War and Peace, and then say, hey, you know what? I might want to go ahead and check that and see if there's any problems with it. It might not be a good idea, right? You're going to get pretty darn frustrated at that point. So now I had an issue with my video card the other day, so I have to do the extend and not the duplicate. So give me a second here to drag this thing over, or the other way. Hey, look at that. And now I'm going to have to do this because it's going to be a little bit annoying. Oh, this is going to be bad. All right, hold on a second. All right, that's good. Sorry, technical difficulty there. I'm going to unplug my machine. All right, let me come back to that while we're waiting for this guy to come back up for a second here. There we go. All right, so we'll come back to my VM issue right here. All right, so if we move on to our next slide here. So part of the prevention process is a lot of people, when we look at, you know, we don't want to just find issues. We want to go ahead and prevent them from starting to be introduced into the source code in the first place. So as my colleague Dawn always says, you don't want to wait for defects to get into your, or viruses to get into your machine and then figure out later that you want to remove them. You want to prevent them from, you know, getting into your, I guess, your computer or your laptop, whatever, beforehand. So some of the things that people do for prevention is coding standards. You know, there's a lot of them out there. You know, you have aviation software, obviously, some IEC 61508, you know, which has a bunch of substandards involved. You guys use like the JSF or JPL, MISRA, DISA, CWE. Depends on whatever industry you're in. You're going to have a whole bunch of different standards that you can take into consideration, right? But what do they all have in common? They're all going to have some sort of rules that can be checked. For example, some sort of, you know, like McCabe or Halstead, cyclomatic complexity, you know, nesting levels, you know, no dynamic memory, all kinds of things. And then they're also going to have some sort of justification as to why these rules are sufficient, right? We wouldn't write the standard if we didn't think it was, you know, the best thing in the world that we can do. And then also, if you're doing something with compliance, you need to be able to generate evidence that you are actually doing these things, right? So these are the things that you have to take into consideration when you're working with coding standards. And you have a difference, right? You have standards that have to do with being compliant, things that you actually have to prove that you're doing. Then you also have, you know, regular coding standards like MISRA or you know, or something like that, where you're saying, well, we don't actually have to be compliant in order to follow the standard. We can take a subset of what we want to do and then create our own and things like that. And that's what a lot of people do. They look at a lot of different standards out there and then decide what's best for them. And so you have to be able to have some sort of tool or robustness that allows you to manipulate that kind of stuff. And then the next thing that you need to look at is security concerns, right? So you're taking preventative measures by introducing maybe standards or some sort of processes or, you know, code review things. But you also need to worry about, you know, security probably, depending on what industry you're in and all of that kind of stuff. Now, I like this chart here basically because it talks about you know, the different, where you're going to find some of the different problems and you know, potentially what you can do to approach them and things like that. So in this case, you know, we use things like pen testing and dynamic testing to look at you know, where the vulnerabilities are, the attack pattern versus the weakness. So, you know, the difference in these things is the vulnerability is actually someone stole something or they've actually crashed your system because they're overloading it with things like that. And so these are actual physical things that you've seen, right? And that's because someone has done some sort of attack pattern, like you know, some sort of SQL injection or something like that in order to cause you know, that overflow or complication to occur. And these are all things that you can do physically once the code is already done to, you know, see where those weaknesses are and expose it. And basically your idea is just to get some sort of small foothold in there so you can start changing the control flow and do whatever you need to do. And then you have the weakness. The weakness is actually in the code level. Like, you know, I'm writing some code and it's weak. It has a weakness that could be, you know, a buffer overflow or something like that. And these are the things that static analysis is going to be able to find, and that's also at the lowest point. If I fix wherever the weakness is in my code, for this buffer overflow, it could actually prevent some of the other different attack patterns from coming in that would be able to expose that. So, that's one of the other reasons that we say this is the lowest point of cost and the best place to start fixing things is right at the code level. Obviously it's good to have a lot of different ways of analyzing your code and preventing things from happening, but you have to take them all into consideration in order to get the biggest benefit. So, one of the next things that, we want to say here, I know I've got a whole bunch of little things on the screen here, but this is about detection and education of code, of these coding standards or your preventative measures that you're trying to employ, right? So, I've taken these preventative measures, but I also need to be able to detect and see what's, what got through and what do I need to do. And so the idea of Clockwork and, probably some other tools out there is basically our main goal is to create tools that fit right into the developer workflow. I don't care if you're using Visual Studio, Eclipse, IntelliJ. We even have our own little IDE or the command line. You can be the developer that loves the fanciest, best IDE out there, or the hardcore developer who says, I only use the command line. Right? The idea is that we need to create tools that actually work with the developer in the same environment that they're working in, so that they don't have to break out of their normal workflow, so that they don't have to worry about, man, now I have a whole other step in my process, right? It needs to be ingrained in what your normal process is, because that's where you're going to get the biggest benefit. So the next step, that we take into consideration is, not only do you need to be able to make it work into your normal workflow if you're making developer tools, because they like to use stuff that's easy to use, low impact, and all of that. But extensibility, such as being able to add your own checkers, having additional checker packs, being able to create your own custom standards and things like that. And then also being able to do your code review process early on in the cycle, right? So maybe if you're coding in your environment and you're seeing some issues and you're like, you know what, I know this is a really critical security violation, I'm going to fix it right now, but these other ones, I'm not so sure about. So it's like fix it or forget it, right? We all know that static analysis, depending on what you have enabled or not enabled, you can see a lot of issues, a little issues, but you as a developer can decide what you want to fix now and what you want to fix later. So the idea is, while you're coding, you fix it or forget it. And if you forget it, you're going to make sure that it gets caught in the code review later on as well, or in the system build and things like that, where people actually verify, is this something that we really don't care about, or is it something that we want to do? So the idea here is to continue to stay within the normal workflow, right? And say, all right, we're fixing all the things that we want to fix at the desktop. Whatever we decided that we don't want to fix, we want to make sure is covered in the code review process as well. And this should still be happening before the time that you have the code already checked in, already into the source control system, already ready to go out to the customer. You don't want to wait until your code freeze time and say, all right, we're completely done. Now let's review it. Well, now you're going to have to go back to the drawing board again, right? So, even if you have your own code review tools or process, still a good idea to keep this methodology in mind. The idea here is to start changing the way you think about using these tools and processes so that you can be as efficient and effective as possible, not only as a developer, but as a team and a company as a whole. All right, let me see if I can get my virtual machine up again. Yay. Okay, good. So, yeah, apparently it did not like... Okay, so I'm going to give you guys one more slide, and then I'll show you what I'm actually talking about. So the other step here, as part of detection, right, is, we've done it at the desktop. We made sure that we're reviewing it and all of that kind of stuff. But the next thing that's super, super useful is, well, I can choose to use this in my own environment, standalone, all by my own self, and not involve anyone else if I want to. But I also have the ability to connect up to a server and be part of an organization or a team or a project-wide project, right? And not only that, that also enables me to collaborate with other developers on the team. and know what's going on, so I'm not fixing things that other people are already fixing and stuff like that. But it also allows me to take a standard such as MISRA, or whatever coding standard you guys want to use, and set it at the server level and change and decide, what do I want my development team to focus on fixing now, right? And you can set all of these things at the server level and let it propagate right down to the developer desktop without them even having to do anything. Or I could set a bunch of issues in my code review process or at the server level and say, hey, I need to assign these to developer Joe, and he's going to be working in his IDE or whatever, and say, oh, look, now I have issues that have been assigned to me. So you're never really breaking out of that mold. You're continuing to do your normal process. And it can be, you can even create your own specialized configurations and things like that. So some good benefits there. So now that my VM has decided to come back up, we'll go ahead and look at a couple things. As long as I don't pull this cable out again. There we go. All right, so what I'm showing you right now, this just happens to be our Visual Studio plugin. Like I said, we have a lot of other ways that you can integrate into your normal coding environment and all that kind of stuff. But what I want to show you here, so let's just do like a quick update. Now I'm not going to go into exactly how it's doing what it does, right? It's stack analysis. Looking at your code, it's making changes, it sees what you're doing. The one difference that we have here within the Visual Studio IDE is what we call the on-the-fly analysis. So you saw, right as I'm typing, right within my IDE here, every time I make a change, the little radar guy is making a little spin around the loop, right? So this is just like a spell checker, just like I'm writing. I don't send out an email without, using the spell checker because I'm horrible at spelling and it would be quite embarrassing. Same thing here. I don't need anybody to see any of the mistakes I've been making, potentially, or I don't need to worry about, man, I'm working on this code that's been here forever and all of that. Let me just kind of, clean it up, right? These are all things that I can keep within my own environment, and then when I check it in, that's when everybody's going to be able to see what's going on. And not only that, it happens super, super fast, right? So, and you can, at the desktop, go ahead and enable, whatever, checkers you want locally. You can say, oops. So just another example. Right here it says, oh, okay, you just created something that's, unused local variable, right? I'm like, oh, all right, awesome. Let me go ahead and use it, So, and then Clockwork's going to look at that again and say, wait a minute. All right, now it's not unused anymore, but, it's always going to be false. So, I mean, that's how quick it works. And that's kind of the idea that we have there. And so the next thing that I wanted to show you guys real quick here is just to take a look when we're talking about standards and compliance and all of that kind of stuff. You can see, we can connect to a project up on the Clockwork server, and then right here, this is where I have, all of my standards and things like that. So, at this point, if I'm working standalone, not connected to anything, I could bring in whatever standards that I want and set them up in here. Or these are all the things that got pushed down and the things that I have to follow, that my boss or this project, it's a requirement now that we have to follow this stuff. And I need to be able to know exactly what I need to do and how to fix it here. So I'm not going to go into a lot of the details about that. How am I doing on time? I don't know. I don't remember what time I started, so I'll show you guys one more thing here, and then we'll get back to the last few slides. So some of the other things that you can do. Oh, good. Thank you. I can just stand up here and talk about static analysis all day. So whenever you guys get bored, just start, falling asleep or walking out, and then I'll be quiet. So one of the other things, so maybe you don't want it to do it while you're actually typing the code. You can, right-click on any file and say, okay, just analyze this one selection or multiple files that I've selected. Or I can just say, you know what, analyze this entire solution and let me get an overall view of everything that's happening. You can get all of this information from an overall perspective from within our web portal as well. But the idea here is the desktop. And, that's where you need to be to get these things fixed as soon as possible. Let's see. So let me go back to the slides real quick. If you guys want a full-on demo, I'll be happy to show you out there. Let me do that real quick. And if you have any questions, I'll be happy to show you anything as we're going through the steps. I just want to make sure I get through all my good, happy content. So now that I have these cool tools and my developers are using it, and we're like, all right, we got this all into the workflow, how do you ensure that whatever tools that you're using are actually going to be successful, right? So you have to be able to measure success in some sort of way, right? You can't just say, hey, my developers are using it. Let's hope it's going good, right? Especially if you have to prove your compliance, because you know what they say when you have to be compliant with something, you have to say, give me this report that tells me, everything that we told you to do, and you better prove it in this little piece of paper right here and show all that kind of stuff, right? So tools like Clockwork, other tools as well, have the ability to do all of these reports and things like that. With Clockwork, you have your defect citing, so you can have a whole a traceability effect here, right? I can see who's making changes to what, the reasoning and the entire history of that particular issue and how it went back and forth, and why we ignored it or why we decided to fix it now or later or whatever. And it's all associated with with the users and things like that. And you can also start breaking things down into what areas you might want to tackle first, or even your statistics. This one's like super useful because it gives you like your issue density and distribution. So maybe you're trying to look at different areas in your code base and decide, man, I don't know what areas to tackle first. You can start filtering down things by modules, by severity, by checker groupings, whatever you need to, and look at the density in those areas, and you can say, oh, these files have a lot of issues. We should probably test that more, or do something more with that, or this depends on how you want to break it down there. And then you also have a web API, so you can pull out all this data and then put it in whatever format you want to be able to spit it into whatever specific report format that you need for compliance and all of that kind of stuff. I already talked about the audit trail. So once you've decided that you have your prevention and your detection techniques kind of aligned, at some point you need to figure out how are we going to mitigate the issues that we do have, right? Let's lessen the effect a little bit of where we're at. So the main thing is an incremental approach. Basically, focus on some subset of violations. Don't overwhelm yourself by enabling everything under the entire sun with whatever tool you're using, right? You can, but after you've gotten all of this data and you have your baseline of what's wrong, take an incremental approach to this and say, all right, let's just start focusing on certain areas that we care about, certain severity levels or certain checkers or things like that. Because that way you're going to be able to start fixing things. You can't fix 1,000 issues at one time. Let's break it down into team, severity, groupings, whatever makes sense to you to be able to actually make a change and start seeing the benefits of those changes. And then as people start learning, that's one cool thing about doing some of this stuff at the desktop as well, is that after Clockwork has told you not to do something about 15 times and it's actually right, you're probably going to not do that anymore because you've learned what it's looking for, and you're getting used to the different practices. Like one of the things about coding standards is that it starts limiting your use of a language, right? It's no dynamic memory, right? So you're starting to have to only use subsets of a language, and it takes a little bit for people who haven't done that before to be able to get used to using only certain things in certain ways in order to be compliant, right? So as people start learning what they need to be doing, you can just add a little bit more and add a little bit more. And then, all of the available metrics and reporting to know where you stand, right? So that's your success criteria. You have to determine, we need to be able to look at the technical debt that we had to start with and start building metrics on this kind of stuff and looking at it and saying, how are we going to measure success with our company? in our development teams and know that we're actually getting out of it what we need, right? And that's where you need to be able to have the the reporting and the metrics and the trending and all of that kind of stuff to be able to gauge if we're going in the right direction. And the other part is make sure you keep it part of your normal workflow. I don't care if you're doing a waterfall design, you're doing agile development, you're using continuous integration tools or build accelerators. The good thing about products like Clockwork, we are pretty focused on the developer. We're looking at the tools that developers are using. We're looking at the tools that companies are using, and we're making sure that we integrate with those things so that you can continually keep it as part of your process without having to make massive changes to what you're currently doing. And it's not a one-time activity, which is what the main point of my conversation today is, right? Don't do it at the end. It's a continuous thing as part of your improvement. Especially with things like security, you're always going to have to continue to keep going through and seeing where you can find new weaknesses and new areas that people are going to start trying to attack you with. Also, you can't expect anybody to start using a new tool without training them. We've done a lot of research and worked with a lot of companies and seen that you're going to be more successful when, A, developers get to pick the tools that they want to use, and B, that they actually are trained and know properly how to utilize the tool in the best manner. You don't do that, and it's going to become shelfware. Nobody's going to use it because they don't know how to use it. They think it's too much work. It gets in the way. And so the key is make sure people are educated on what the benefits are and how they can use it most effectively, right? Because sometimes people are just kind of using it in a different way or a weird way, and they don't really get how it fits, right? So if you can train everybody on how to use it properly and how they can get it to work with their current workflow, then there's usually going to be a way, right? And psychology is key. When you start using tools like static analysis or dynamic analysis tools, do not use it to beat your developers over the head with it. Do not use it as a tool to say, you have done A, B, and C wrong, and now we're going to do this, that, and the other. No, that's the whole psychology thing. It's not some sort of tool for embarrassment, right? It's meant to be able to help you write more reliable, secure, robust code. And that's what we're talking about. You don't want people to not use it because they're like, I'm afraid someone's going to do some sort of finger pointing and tell me, I'm some horrible person. And that's the other reason why you want to use it at the desktop, right? So you can try and get as much of that stuff done beforehand in case people are trying to beat you with it. But we don't see that. We don't see that so much anymore. But whenever I get that question, how do I know who did that? Well, you can find out, but that's not really the goal, right? The goal is just to get better. All right, so last slide in summary. Basically, speaking of our third generation source code analysis, basically it's going to be the point of greatest time savings for your developers, right? Because you're doing it, you're fixing compiler warnings and compiler errors. Why wouldn't you want to fix some critical security vulnerability as well, right when you're doing it, right when your head is right there? That's when you're at the most ingrained, pliable state. You're all creative. You're thinking about solutions and fixing things, and that's where you need to be when you see problems and how to overcome them. It also, we think it definitely gives you a better adoption rate, right? When you start using those things, when people feel like they own the tool and that it's part of them, and they start using it. You can do prevention. We just talked about that as well. With coding standards and threat modeling and things like that. And then, being able to detect the issues at the desktop, whole point of the conversation, ensure, find it early. And then focus, fix, repeat, right? Make sure you keep it a continuous part. So that is my presentation. I've got a whole awesome demo to show you guys. If you want to come on out to the little hallway area, I can show you a lot about how the tool works and some of the different environments or reporting, metrics, whatever you guys want. And you can feel free to ask any questions. I am Jessica Jaclin, and I'm the product manager for Clockwork. And then we also have Don Dionato over here, and he is our account executive guy. So thank you very much.
Demonstrated it as a spell checker.
Yay! So we want that shock value.
No,
Yeah.
That's good. How hard, let me ask one quick question. How hard is it to put in custom standards? Did you show that?
Oh, okay. So if you, okay, there's a couple different things that you can do. We have, with the extra checker packs that we have like over 500 different checkers for C and C++, 180 for Java, and we have like 50 or so for C#. So if you have a custom standard, we can help you, or you can map the existing checkers that we have to your standard. That is super easy. I mean, it takes just a few minutes. You also have the ability to write your own checkers if you find that you want to do something very, very specific with, like, I want all global variables, you know, you can write your own. And that's a little more, that takes a little bit longer, but not as bad.
The reason I ask is that some corporations have their own set of standards
Yeah.
that are like nobody else's.
Oh, yeah. No, we deal with that all the time. Super, super easy to do. So,
Okay, very
yep.
good. Thank you.
Yep, you're welcome.
Okay, let's see.